Hi, everyone. This is Sebastian Traeger, Managing Director of Reliability Center, and we are back with another episode of Reliability 4.0. As always, we're on a mission to help make the world a more reliable place. And today I am excited to be joined by Brian Heinsius with Eco Materials, which is newly a part of CRH. He's going to tell us a little bit about the company in a minute. Brian, thank you so much for joining us today. We're excited to have you.
Thanks, Sebastian.
Great. Well, just before we started this podcast, we started talking about eco systems, or just eco for short. We'll just call it for the rest of the time. And I know you took on a very interesting role at that company to start doing some interesting things. So I think we'd just love to hear a little bit about the company and then your role within the company.
Eco Materials, we are a cementitious material supplier. We provide both fresh ash and harvested ash from power plants. The company started out as really three different companies back in the day, and they were put together as Eco Materials. We also have a part that's called Eco Cement, which we do additives to natural pozzolanic material, which is volcanic ash. And what I do is I was hired as the senior reliability manager for the harvesting side. It's a little bit a different track than what Eco is used to. Normally what happens is power plants burn coal, they have fresh ash, it goes to a silo, and we transport and market that into the concrete industry for ready mix concrete to displace a certain percentage, depending upon the mix, of Portland cement in concrete. What we realized, or what the company realized, is that the use of coal has a finite life, right? There's going to be a point at which that fresh ash is not going to be available anymore. And then there was also this piece on the power plant sites where they have all this landfilled ash that they've had since their inception that they need to try and do something with rather than just leave it sit there in a hole in the ground somewhere. So what we do is we go out and we mine this landfilled ash. We process it. Mostly that is a screening, grinding, drying process. And then it goes right back into the stream with fresh ash to be sold back out into the cement, ready mix cement manufacturers. The other side of it is the eco cement side is we take and we mine a pozzolanic, sometimes referred to as Roman cement. It's a cementitious material that comes from volcanic ash. We treat it with some specific chemicals and we can replace 50% of Portland cement in a concrete mix using it. That's mainly on the West Coast where we have that right now. We have a plant in Oregon that's doing that. We had a plant in Kirkland, Arizona also that mines pozzolanic and treats it. And then we're a growing company, so we're working to grow that market and looking at other utilities that have burned coal currently or in the past, and also other pozzolanic deposits that we might be able to exploit moving into the future. In September, we were purchased by CRH to be part of their American Cementitious Materials. And now we are a partner with Ash Grove Cement.
Okay. So you're basically supplying the cement that they're sending out, I assume.
We supply the fly ash materials that then gets blended with the Portland cement and into ready mix concrete plants.
That's fascinating. Just going back to the example you gave of going to plants and saying, hey, you've got some ash in the ground. What if we took it out and did something with it? Presumably, that's like a never ending amount of plants you could sort of go to and do that with. Is that take a long time to mine that out?
It can, yeah. And most of the contracts that we have are 20-year contracts, right? So the current contracts we have are 20 years where we go in and remove that. Does a couple things, right? It displaces some of the high carbon Portland cement because cement is a high greenhouse gas producer. So we can offset that carbon by taking something that's already burnt the carbon out of it, so to speak, and displace that. But it also cleans up those landfills for the power plants also.
Yeah, that's amazing. I love that, how it does two things that are really beneficial. That's fantastic. So then your role there, you mentioned coming in to kind of start a new initiative. Why don't you tell us about that?
I've set up all the reliability and maintenance practices at the new harvesting sites. So first off, we started off setting up a Maximo system, building all the assets, building all the PMs, creating the hierarchy, setting all those things up. The other pieces that I've done have been putting in the reliability practices. All of our sites are relatively small. Typically, we have 6 or so maintenance techs is all we have on the sites.
Okay.
So very small, sitting under a maintenance manager who's very much a working maintenance manager. manager. And so what I've tried to do and my team has tried to do is set up these sites so that we can monitor them remotely. So we've been putting in PDMA systems to monitoring, PDMA-I, so we can see the things on a dashboard in the web. And then we put in UE systems, remote monitoring insight, so we can see and lubricate all the bearings on critical assets remotely. And it really helps for me to be able to look at those sites remotely and then provide work orders. I have a planner that works for me as well that does the regional planning for the sites, and then they build the planning and scheduling for the individual sites.
So you're able to, just so I understand this process, you're able to see what's going on at the sites and then understand the conditions or the different things going on, and then actually send instructions and work orders for them to do.
That's correct, yes. As we started out here, what we've done is monitor the ultrasound, right, coming back from our online system, but we also have a handheld unit, and we monitor the dB level of those bearings that we're monitoring just to make sure that the monitoring system is doing what it's supposed to do. And as we've progressed, right, you become more and more confident in the online system.
Excellent. So, and how did you test that site by site? What was the kind of the rollout strategy there?
Well, we started out at one of our first major sites to come online, and we started out there by using the wired system. So we put the wired system in. It worked really well. We were able to monitor and ensure that lubrication was happening on a regular basis on our critical high-speed exhaust fans, combustion air fans, and other critical assets, right? But we also, like I said, we did our normal maintenance routine, right? Where the lubrication tech would go out with the ultrasound gun, take a dB reading. We had an 8 dB increase. They'd lubricate. Pretty standard across most of the people who are doing ultrasonics, right? But we just correlated those two together, and so we could see that the system was operating as it could be. And then as we put on additional sites, that we've kind of transitioned away from the wired system to remote sensors. The remote sensors on that system then gave us single axis vibration, temperature, and dB, all three, which gave us more information, right? That more information then translates back into, hey, site XYZ, your temperature on this bearing has been going up for the past several days. You might want to go out there with your thermal camera and take a look at it and make sure that what we're seeing online is actually what you see in the field. Same thing with vibration. We still have a vibration company that comes in on a monthly basis and does our vibrout. But my goal in this whole process is to get to the point where the sensors become the on condition for sending out a vibe tech, for sending out an IR scan, for sending out a tech to do ultrasonic readings. Just because we have such a small footprint and such a small amount of maintenance personnel on site, right? We've got to be able to figure out how we utilize that technology to help us be able to bridge that skill gap and labor gap.
And that does make a lot of sense. So thinking about results or KPIs, how have you tracked that? Do you have kind of a, here's what it looked like before to now, or just even starting fresh? How do you track results of that process?
Our results are still tracked in our work management process. So we still look at PMs, PM completions. We look at assets that are in a red, yellow, green status. And we try, obviously, to keep all of them in green or yellow status. And if they're in a red status, then that means that something needs to be actioned within the next work management cycle. From a reliability perspective, it's really about asset health. And we haven't gotten to that point yet because all of our sites are new. In fact, we've got 2 new sites coming online within the next month, which will, of course, is going to quadruple the data that we have coming in. And our goal then will be to take that data and push it along with the data from the PLC into Maximo Health so that we can see what assets and rate those assets based on a health score.
Have you experimented with or found AI helpful thus far in sort of helping to analyze some of that data?
So yes and no. The first time I ran AI against a bunch of texts that we were getting in from operator reports, I thought, wow, this is great. I got this Pareto out here and it's telling me that I can do this and I can do that. And then the more I started to dig into it, the more I started to realize how wrong it was in a lot of instances, that it was mixing words up and it would count things that it shouldn't have counted. So I've worked through prompts, iterations to be able to narrow the focus of what it's looking at and tell it, look, I only want you to associate these terms with this. And now I'm actually getting the prompts down to where it's pretty reasonable, right? So I can create a Pareto based off of text operator logs and kind of see if those match up to what we're seeing in work order history, along with what we're seeing in our remote sensors.
So you're starting to see use cases for AI and helping to do this, but presumably not necessarily yet starting to kind of predict or tell you, hey, here's based on early signs of data, here's what to go do.
The boss I had that hired me, right? He's no longer with the company since our purchase, but he was pushing hard. Got to do AI, got to have AI, got to have it. And I said, look, we can put AI in right now, but all it's going to do is get us to the wrong decision faster. So what I've been trying to do is build that rock solid base. First, we have great asset data. We know what our motors are. We know what our bearings are. We know all of our assets are, that data is confirmed and in the system correctly, that we're following our work management process so that we have work orders that are correct, and that we have sensors that are tried and true, that we've tested them against physical vibration analysis. We've tested them against physical ultrasound, and that data is good. And now our next step is going to be pulling data from our historian, from our PLC. That's the piece that I don't have at any of our sites, don't have done yet. And then let AI get those against a set parameters and start to tell us and predict, hey, we saw this before and this is what you can expect.
One of the, our company really specializes in root cause analysis. So I always like to ask our guests, what are they doing in the root cause analysis space? So what does that look like for you all, especially with kind of smaller sites?
So really, we're in the infancy of root cause analysis. That's going to change now with us being basically a partner with Ashgrove. And we're going to start using their process for root cause analysis, but we have been using mainly just a simple 5-why process. It hasn't been very detailed, but we are trying to track that information so that we can get it into the system. So It's just another data point.
And that sounds like one of the things that you're really pushing for is let's get clean data. We know that we can get more and more sophisticated about the analytical tools we use. But if we don't have that underlying data, it doesn't really matter how good of tools we put on top of that data. It's not going to give us good answers.
My push for the last 2.5 years with ECO has really been, let's build that super rock solid foundation of data and information so that when you open Maximo and you look at an asset and you go to the specifications tab, they're right. I've had several people putting that data in, and my comment to them is, look, I'd rather have it be empty than wrong.
That's good. That's smart. Yeah, don't guess. Don't give me
That's right.
junk data. That's the worst that we could get. If it's an unknown, we can make assumptions or we can go back and fill it in. But if it's there and it's right next to good data, unfortunately, there's no flag in databases that say how good the data is, right?
And putting that into AI context, one of the things that we've found from a AI perspective is that we can take nameplate pictures and feed them into Copilot and tell Copilot, hey, tell me what this is. And Copilot does an exceptionally good job of parsing even a relatively bad photo of a nameplate and putting it all out there. So you get horsepower and FLA and all of those things off that nameplate. And it will even go out and find it on the web. We have several Nord gearbox gear motor combinations, and it'll go right out to Nord and pull it off of their site and say, this is what it is.
Yeah, I agree. I think AI does an amazing job just taking data off of photos, right? We're starting to get to where it's like, hey, bad data, there's no excuse because just give a quick audio recording or take a photo or something just to capture a reality as much as you can, and then it's sort of captured.
We also were doing some spare parts. So we had a whole bunch of spare parts on a shelf at one of our older sites. It was online 2 years before I even started. And there's all these spare parts on the shelf and nobody knows what they are. Of course, they're taken out of the box already. So, we were taking pictures of them and feed it into Grok. And it was like, gives you an exact description of what it was, even the manufacturer. Not always, but better than 50% of the time, it would tell you exactly what it was from just a basic picture.
Fascinating. And better than what you would have guessed, probably.
Yeah, better than what you were guessed, or absolutely faster, right?
Well, it's been great having. One thing I always like to kind of end with guests is just kind of one final word. And the way I usually frame that is if you either were talking to a new engineer, reliability engineer, and wanted to give some advice, or somebody coming into a new environment, what advice might you give them that you've gleaned from your career and your experience?
To me, it's just never stop learning. I also work as an adjunct professor, so I constantly am trying to teach. I'm a master electrician by trade.
Wow.
When I was working as a journeyman electrician, right, I can remember the master electrician that I was working for telling me, look, you know what the difference between a journeyman electrician and a master electrician is? And it's like, you get paid more, He's like, no, it's that once you take on a master role, your job is to bring all of the apprentices and journeymans up. So I've kind of taken that to heart, and I do that. If any chance I get, I like to teach. Just continue learning, right? And AI right now is one of those places. You keep learning. I keep trying to figure out the prompts. I keep trying to figure out how they're working and what they're looking for, and to build that intelligence in myself, not just in the AI.
Well, I just really appreciate what you said earlier, just even saying, hey, if we use AI today, just the way it is, we're going to get bad answers. I think people can sometimes have the approach of like, I'm not going to touch it because I don't get it, or I'm going to dive in so fast and just trust it all. So I just really appreciate your attitude. Seems to be like, yeah, we definitely see this as a tool that's going to be useful, but let's make sure we understand it enough to get the value out of it and don't get wrong answers.
Just get you the wrong answer faster, right? You have to be careful. And in most of the industries, and some probably more critical than mine, you just can't afford to have that. You can't afford to have it give you a wrong decision.
Well, it's been great talking to you, Brian. Thank you so much for joining us. Again, this has been Brian Heinsius with ECO. Thanks for joining us. And to all listeners here, we're really about helping reliability engineers and just really anybody learn more about using technology to solve problems and thinking about how we can do a better job thinking well about the roles that we're in and how we can apply some of the newest technologies out there in things. Of course, if you're looking for root cause analysis resources, maybe training or other materials, check out reliability.com. And of course, if you want to dig deeper with the software platform, check out our easyrca.com. We'd be happy to talk to you about that. But that's all we have for today. Thank you all again in joining us on this journey of making the world a more reliable place. Thanks again, Brian, for your time, and we will see you all on the next episode. Thanks so much.
Thanks.